Good morning, children. In the last two videos, we discussed about the definition of a square number, what are the properties of a square number, and what are the interesting patterns showed by square numbers. If you go into the definition, any number m is called a square number if m can be written as n square, where n is a natural number. After learning about squares, let us see how can you define square root. Take some square numbers as 100, 36, 64, 81 and so on. They are all square numbers, and how do we know that their square number is 100 can be expressed as the product of natural number 10, and it is the product of 10 into 10, or it is the same as 10 square. Also, 100 is the product of minus 10 into minus 10, where minus 10 is an integer. Minus 10 the whole square is also 100. 36 can be written as 6 into 6 or 6 square, where 6 is a natural number, whereas it is also a product of minus 6 into minus 6 the whole square. 64 is 8 into 8, 8 square, or minus 8 into minus 8, minus 8 the whole square, and so on. Thus, the square root of 100, the meaning is which natural number multiplied by itself is giving you 100 as the square, or which integer multiplied by itself is giving you 100 as a square number. That is, square root of 100 is, it can be either plus 10 or minus 10. Of 36 is either positive 6 or negative 6. Symbol we used here is called the radical sign, and for the word square root, even though the index 2 is the number to be mentioned, we never used to represent it. It is understood that the radical symbol here shows that it is a square root. But further on, for the concept of cube root, fourth root, we used to write the index along with the radical sign. There are three different methods of finding square root for a perfect square number. The first method is by repeated subtraction. The second method by prime factorization, and the third method by long division method. By long division method. The repeated subtraction method has already been mentioned as the interesting pattern, that any square number can be expressed as the sum of consecutive odd numbers. That is, when you subtract the odd numbers from the given number, the number of times you are subtracting the odd numbers, so that the resulting answer is 0, will give you the square root. Let us take the example of 64. The first method, 1. Find the square root of 64 by repeated subtraction. 64 will be subtracted by the first odd number 1, 63. The next odd number is 3. The next odd number is 5. Next number is 7. Next number is 9. With the next number 11. The next number as 13. Next number as 15. And the remainder turned to be 0. Thus, how many times you have subtracted is, you have taken step 1, step 2, step 3, step 4, step 5, 6, 7 and 8 steps. By subtracting 8 times, you got the answer as 0, or square root of 64 is equal to 8. Thus, the first method of repeated subtraction is by subtracting the odd numbers of 1, 3, 5, 7, 9, 11, 13, etc. in order till you get the subtraction or the difference as 0. Count the number of times you have subtracted. That will give you the square root of the number. When square root of perfect squares which are larger numbers to be found out, the repeated subtraction method will be time consuming. The second method is by prime factorization. What are prime numbers? Prime numbers are the numbers which have factors as 1 and itself. That is, the numbers which have only 2 factors, 1 and itself, are called prime numbers. The prime numbers 2, 3, 5, 7, then 11, 13, 17, 19, 23, 29, 31, 37, 41, 43 and 47 are the prime numbers below 50. When you observe these numbers have only factors as 1 and itself. Now, what is the method of finding square root by prime factorization? Let's do with a bigger number of 1225. Find the square root of 1225. 1225 has to be divided with the first prime number 5. 5 2s are 10. 245. You can divide in this side, divided by 5. 5 2s are 10, 22. 5 4s are 20, 25. 245. Again with the prime number 5. 245 divided by 5, 49. The next prime number is 7. 7 till the remainder turns to be 1. Thus, square root of 1225 can be written as square root of 5 into 5 into 7 into 7. We know that the index is 2. That means for every 2 factors, the square root will come as 5 into 7, or square root of 1225 is 35. So when you find the square root of a perfect square number, the prime factors will occur in pairs. For a perfect square number, the prime factors will occur in pairs, and one of the factor will be taken for the square root of that particular number. Two more examples I will explain. Before that, just copy the prime numbers in your notebook, and one is neither prime nor composite. One is neither prime nor composite. It's a very important factor in maths. Find the square root of 1764 by prime factorization. Express it as the first prime number is 2. You can divide 882. Divided by 2 will give you 441. The divisibility test, 4 plus 4, 8 plus 1, 9. That means a number is divisible by 3. The division answer is 1 time. 4 3s are 12. 21 will be 7. 7 plus 4, 11 plus 1, 12. That is, it is again divisible by 3. 4 3s are 12, 49. You can see the prime factors are occurring in pairs. How to present the answer is square root of 1764 is the same as square root of 2 into 2 into 3 into 3 into 7 into 7. What of the factor is coming up as the square root? 1 factors will come out. 2 3s are 6, 6 7s are 42. Thus the square root of 1764 is 42. The next example of 4096. 4096 by 2. 2048. The prime factor 2. 1024. 512. With the prime factor 2, 256, by 2, 128, by 2, 64, by 2, 32, by 2, 16, by 2, 8, by 2, 4, 2, 2, 1. For here itself you can group 1 factor. Square root of 4096 can be written as 2 into 2 into 2 into 2 into 2 into 2. 2 2s are 4, 4 4s are 16, 16 into 2 32 into 2 64. So the square root of 4096 is 64. Another type of question in your textbook exercise 6.3. Find the smallest number by which 252 has to be multiplied so that the resulting number is a perfect square. We know that numbers ending with 2378 is never a perfect square. They are asking you which is the smallest number to be multiplied with 252 so that the resulting number is a perfect square. A similar pattern, find the smallest number by which 396 is to be divided so that it becomes a perfect square. The question says that number 252 is not a perfect square, 396 is also not a perfect square. We have to multiply 252 with the smallest number. We have to divide 396 with the smallest number. The method remains the same, the prime factorization. And the prime factors, we know that it should occur in pairs. 252, the prime factors are 126, by 2 is 63, by 3 is 21, by 3 is 7, 7 and 1. 2 has occurred in pair, 3 has occurred in pair. The prime factor which has not occurred in pair is 7. Therefore, 252 has to be multiplied with 7. That is, if you multiply to get a perfect square number. And what is that number? It is 252 into 7. The number is 1764. What will be the square root of that number? No need to calculate because the square root will be 2 into 3 into 7. It will be 2 into 3 into 7. Or if you want, you can calculate in this side. The same answer will come. It is 6 7s are 42. A similar pattern, the extra factor has to be divided with 396 by 2 is 198 by 2 is 99 by 3 is 33 by 3 is 11. That means the number 396 should be divided by the extra factor here 11. 11 so that what is the resulting number? 396 divided by 11. 3s are 33. It is 30 so that 36 is a perfect square number. Perfect square number, and what will be the square root of 36? It is 2 into 3, which is equal to 6. So the same pattern as you find the prime factorization, whichever factors which are not occurring in pairs, either it should be multiplied with the same pair or it should be divided with that factor so that the resulting numbers will become perfect squares. The last type of question which you can find in exercise 6.3 is find the smallest square number which is divisible by 4, 9 and 10. Which is divisible by 4, 9 and 10 means it should be a number larger than all these three numbers. That is, it should be a number which is a multiple of all these numbers, which gives you an idea that you have to find out the LCM of 4, 9 and 10 as the first step. So the first step involves to get a multiple of these numbers which can be found out by the least common multiple. So the LCM of 4, 9 and 10 is 2, 9 and 5. Again with the 2, 1, 9, 5. With 3 it's understood, but still the workout should be complete. The LCM is 2 into 2, 4, 2 into 2 into 3 into 3 into 5. 2 2s are 4, 4 into 9 into 5, 36 into 5, which is equal to 180. Now, the next step is find the prime factors. It's already here. The prime factors of 180 are, it is already here, by 2, 45, by 3, 15. Now, 180 is the same as 2 into 2 into 3 into 3 into 5. Here, the prime factor 2 already occurs in a pair. It's already occurring in a pair, and here, the prime factor 5 is not in a pair, or that 180 should be multiplied by 5. That is, which is the smallest square number? The smallest square number is 900. Or from here itself you can understand find the LCM, and in the LCM, whichever is the factor which is not occurring in pair, that factor has to be multiplied with the LCM, which will give you the smallest square number. One more I will explain the same pattern. Find the smallest square number which is divisible by 6, 9 and 15. The first step is to find the LCM, and from the LCM we can understand what are the factors to be multiplied with. LCM of 6, 9 and 15 is equal to, with 3, 2, 3 and 5. Again with 2, 1, 3, 5, with 3, 1, 1 and 5, with 5, 1, 1, 1. That is, LCM is equal to 3 into 2 into 3 into 5. That is, 3 is occurring in pair, into 2 into 5. So, what will be the number which will be the smallest square number? Therefore, the smallest square number will be 3 into 3. It already occurred in pair. 2 into 5. That means one more 2 should be there and one more 5. That is 9 into 10 into 10. That is 900. So from the LCM itself you can understand the extra factors which need to be multiplied so that the final answer will be a square number.